Hello, my name is Tom McPherson. Welcome to my final project for Harvard's CS50p. My project is about airworthiness tracking made easy for general aviation. I'm a pilot, and tracking whether an airplane is in a condition to fly or not is always a bit tedious, and my application makes that a lot easier. So what is airworthiness? And there are a couple of rules that relate to it. One is that no person may operate an aircraft unless it's airworthy. Well, that makes a lot of sense. We all want that. And then the pilot in command of the aircraft is the person responsible for determining that. There are a lot of people involved in managing an aircraft, but ultimately it's the pilot in command that has to make sure. And how does he do that? Well, he has to search through logbooks to make sure that the aircraft is in a condition to fly and it's been approved for flight, and we'll talk more about that in a minute. So how does the pilot determine that the aircraft is airworthy? Well, the federal regulations, and this was Part 91 here, says that after maintenance or any preventive maintenance or alteration, that a maintenance record has to be entered into some kind of logbook. There's a lot of details about how this is done and what needs to be included, but the pilot in the command has to look through these logbooks to determine if all of the proper maintenance has been done. So what's the problem? Well, the problem is there are a lot of logbooks and there are a lot of entries, and these airplanes may have a lifespan of 10, 20, some of them are even 50 years. And so there's a lot of logbooks to search through to try to determine if the aircraft is airworthy. Of course, you have to only look at the most recent ones, but some of the items are only maintained every 10 years. Over here, you can see for this Cirrus over here, some of these dates go more than 10 years, the oxygen bottle, for example. So it's quite tedious and time-consuming for the pilot if they're not familiar with the aircraft to make sure it is indeed airworthy. You can see from the prior photograph the stickers are typically put in logbooks. There's also some handwritten. There are multiple logbooks even for one system. The status is always changing. Some of the systems on the aircraft have to be maintained according to the number of flight hours, and as you fly, there's the due date, the time to the due date changes, or the number of hours to the due date changes. And then you have to review every subsystem and every major system on the aircraft before taking a flight, and it's hard to have that at your fingertips when there's a pressure of a flight looming. So I wrote an app that has several functions. It allows you to track, report, and predict airworthiness status. So there's some configuration commands. I used a command line interface for this. There's a configuration commands where you put in the maintenance intervals for all the systems you're interested in. As maintenance happens, you record the maintenance actions, and then the aircraft time is maintained in a separate log in a Google Sheet that is accessed with my app to run a report and do an update. So a calculation is made relative to the day it is and the number of flight hours that the aircraft has on it, relative to the data that's stored in my app. So here's an example of the app in action. If you're starting cold, the plane is first initialized. Here's an aircraft, 527 Whiskey, that's a Mooney M20R that's manufactured in 2001. So there's initialization. Then the next command here enters a major system. Their major systems are engines, propellers, the airframe itself, and the avionics. Within each of these systems, there are subsystems. So here we're adding a subsystem of a magneto to the engine with this command. And then once the commands and the maintenance actions are done, you can run a report with the -R option There's configuration reports that can be run, maintenance status reports, or you can run all of them at the same, all the reports at the same time. All the commands are documented, with help. Here's a screenshot of the beginning of the help function. So it's relatively easy to use, and as long as you're entering the maintenance actions as they're happening, it's pretty quick to run a report and to determine if the aircraft is ready to go or not. So here's an example of a report. I used some of the libraries in Python to generate a nice looking report. This happens to be a maintenance report for a particular cirrus. It's got 4 major systems over here. The subsystems in the engine are the magneto, the left and right magnetos, and the oil system, for example. The time in service for this particular oil change is only 2.6 hours. It's got 27 to go. It's due on this date. And there's similar due dates are calculated for all the other systems in the plane. The airframe has a lot of subsystems on it, as you can see. Now, some of them have to be done every 50 hours. Some are, a year. And some things go 6, 7, or even as much as 15 years here. And there are also systems that don't have required maintenance intervals. They're serviced on condition, but they may be worth tracking. You may want to know how long your tires have been on the plane, for example. So some enhancements I'm considering is to make a graphical user interface instead of command line, or using JSON instead of Pickle for persistence so you can read. Maybe deploy this for a user community. And there are a lot of commands might be entered over time. It might be useful to have a log of all the commands entered if you needed to recreate. So thank you for watching the video. I enjoyed doing this project, and if you have any comments, let me know.